All right, so just a couple things that you can really see that typically stick out is we went from a 3% asymmetry and on the 5.5 miles per hour run, so there's a little bit more time spent in ground contact on that right side. And we find with running, that 3% has been, within the standard deviation of what's considered to be normal. And beyond that, we start to move up into 5%. So it looks like we're spending a little bit more time in contact. So that often can mean, in this case, especially when it comes to running, the fact that someone can run, maybe it's not necessarily related to pain, but it's turnover, right? So that person is spending more time in contact with the ground for whatever reason. Could be because of pain, but usually it's going to be as a result of weakness. And to kind of tie some of these things together, when you look at the attack angle, so on that, on the left side, she's reaching and she's got, a negative 11 degrees. So in other words, she's in 11 degrees of dorsiflexion, or at least neutrality. So she's reaching out far enough, and that angle is actually relative to the ground surface, whereas she's landing pretty flat foot on this right side, which again, you see this progression to where, when she's running slower, it's a much more normal and sort of symmetrical attack angle when she's making those steps. The impact forces, I wouldn't say that those really change. And historically we've seen sometimes people have, the quadricep deficit that we're trying to overcome, and that could be one of the reasons for, this lower turn rate, and she's trying to compensate for that as she's going through her step cycle, and why, she wants to land on this flat foot, and maybe not able to propulse on the left foot, quite good enough is what she would want to. The other things that kind of stick out, if you look at the propulsion rate down here, right? So we're at 55 and we're at 68%. So, and not to get thrown off too much. And the reason for that too, it's a couple things. One is because she's not really going into, if you look at the attack duration, is also relatively shorter. And the reason is that she's landing flat-footed. So she's spending a little bit more time in the ground with that right foot. And that's where the discrepancy kind of comes in with the propulsion duration, is she's going into toe off sooner, um, but not turning it over quite as quickly. And that's, sort of the limitation in her leg being straight, and just at the way she's trying to compensate motor control mechanisms, saying that she wants to maintain, basically the same stride from right to left. And so that could be a compensatory mechanism as to staying in contact, and why you see a 68%. So in other words, we break that down into when you heel strike, into foot flat, and then into toe off. So we break that down into percentages. Um, but in the running phase, it's a little bit different. We move obviously much more quickly. So instead of heel striking and then going into sort of the foot flat and then into the toe off, she's really midfoot striking and then going into that toe off. And so that's why we see that propulsion duration a little bit longer. And again, that could be related to some degree of turnover inefficiency. I think what would be interesting is if there's any vertical jump comparison, looking at ground contact time between the right and the left. And if that can't be calculated, maybe looking at jump height or flight time, if that's something that you guys are able to look at. If that can't be compensated, then simply doing the side hop, right? So that 30-second side hop, and my guess is you would see a lower number on that right side than you would on that left side, which would be indicative of longer ground contact time, um, and lower turnover rate. So not really being able to compensate for that time. And again, this is consistent. So you see in the 5.5 miles per hour, and even up top here when you're looking at the attack angle, it's still different, but she's getting into that flat foot position as she's increasing that speed. If we could go up to 7.5 miles per hour or actually see something closer to a sprint, based on what we see here, potentially we may see that delta, that differentiation, further increase as a result of that. Looking at the angulation, so remember that this angulation is looking at pronation, supination, or inversion, eversion of the midfoot to the rear foot in that frontal plane. So strike angulation, she's fairly normal in 26 to 20, even on that slower speed. No cause for alarm. But we start to see this sort of progression in the midfoot angulation is where she's not going back into inversion, right? Which again can be related to supination for whatever reason on that right side, and that's probably one of the reasons she's spending a little bit more time in contact during that propulsive phase, percentage wise, overall. Again, biggest difference I really kind of see is, the amount of time that she's spending in contact with the ground, which is turnover rate. Sometimes we see that in the deficient leg. Sometimes we see it in the opposite leg, just depending on how much time was spent on the good leg and the bad leg, during the rehabilitation process. But I would say, if it is a contact time and being able to turn over that step, back to some single leg stuff, and obviously not as much a concern during acceleration, but really on deceleration, slowing down and changing direction. So, that doesn't turn into a future injury.